Okay, in this video we're going to talk about how to take the derivative of a couple inverse functions, inverse sine, inverse tangent, and then kind of a general rule about derivatives of inverse functions and how they relate to the reciprocal of the derivative of the actual function. So let's go ahead and get started with an example problem. So here's one that involves inverse sine and inverse tangent. So why don't you pause the video, try to solve that one on your own. All right, if you were able to come up with a solution to this one, you should have seen, like our other ones, we're going to be using the product rule to solve this. So if we go through and solve it, we're going to take the derivative of the first function times the second function plus the first function times the derivative of the second. All right? So that's about it, okay? You know, you can get more complicated examples of taking derivatives of these inverse functions when we talk about the chain rule in a little bit. But for right now, as long as you can just apply these formulas, that's all you need to do. So let's look at this last formula down here and do a couple problems with that, because that's usually the one that's the most confusing. So let's look at this problem right here, okay? So try to apply this formula right here to the problem to the right. See if you can get an answer real quick. Pause the video. All right, so if you tried this one, there's a couple little tricks to it. But basically what this formula is saying, that the derivative of the inverse of a function, we'll call that function f, evaluated at this point x equals f of a, is just 1 over the derivative of the function f at x is equal to a. So that's very, very wordy, but it's a pretty simple application when you get into it. So this is also kind of a cool thing because it's telling you that the derivative of an inverse function evaluated at a point that was originally the function evaluation of the original function is just the reciprocal of the derivative of the original function at that particular point A. So again, super wordy, but when you see it visually, it's actually somewhat intuitive, and it's a very kind of elegant equation. So if we go through and solve this thing, x equals 8, that's telling us that we're looking at f of x is equal to 8. That's this part right down here, okay? So if our function is f of x is x cubed, we're going to be looking for the x value that causes x cubed to be equal to 8. Well, that's going to be x is equal to 2. So if we want to find what this derivative is, that derivative will just be 1 over f prime of 2. Well, if f of x was x cubed, f prime of x is 3x squared, so therefore this will be 1 over 3 times 2 squared, which is 1/12. So that will be the answer. So when you look at how it's actually applied, it's really not terribly complicated. It's kind of just understanding where to put the right numbers in the right place. But let's pretend we didn't have this cool little equation right here over to the left, and let's pretend we had to just go through and calculate the inverse of x cubed. Now I hope you remember how to do this stuff from pre-cal. I'm not going to go over that. If you're confused how I get the inverse of this function, I would suggest you kind of look, there's, I think in chapter 1 of your book, there's a review of inverse functions. But if f of x is x cubed, that means that the inverse function of that is x to the 1/3. So if we wanted to evaluate the derivative of x to the 1/3, well, by the power rule, that would be 1/3 x to the negative 2/3. So if we evaluate that at the initial point we wanted to evaluate it, which was, remember, x equals 8 up here. If we just plug 8 into that, plug this into your calculator, this will be 1/3 times 1 over 8 to the 1/3 squared. Well, 8 to the 1/3 is 2. 2 squared is 4. And if we go through this, we just get 1/12 again. Okay, so even if we didn't have this formula, if you know how to take an inverse, you can find the derivative of an inverse function. But let's look at another application of that last equation down there. So let's say we got a function that looks like this. This is actually an old AP test question. Okay, so this one's worded slightly differently. So read this one real quick and see if you can actually just answer it on your own right now. All right, if you've given it a shot, this one takes a little bit more explaining, but it's really using the same formula. So what we have is, if g of x is the inverse of f of x, or should have been a negative 1 right there, then that means that this is just a property of inverses. Remember, inverses just means you flip-flop x's and y's. So if f of a is equal to b, that means f inverse of b will be equal to a, okay? So this is how that equation that we got on the previous slide, that's what that turns into, that reciprocal equation. So therefore, if we're looking for g prime of negative 2, that's going to be 1 over f prime of, and what we have to do is find what that a value is right here. And to do that, you need to understand this concept of inverses. So if you weren't able to get the answer the first time, based on what we just said, try to pause the video again and get the answer this time. All right, so if you've done that, from this information right here, if g of negative 2 is 5, that implies that f of 5 is negative 2. And negative 2 is that value we have in here. So again, that's our value for b. Remember that if f of a is equal to b, that's basically saying, what is a? That's saying, in this case, a is this value 5, okay? So this will be 1 over f prime of 5, which they were nice enough to give us that value right here. This will be 1 over negative 1/2, or negative 2, okay? So that's how you solve one like that. So again, if this is really confusing for you, go ahead and rewatch this video. See it happen a couple times, okay? If it's still confusing for you, let's come in during tutorial or during class and ask some questions. To be honest, these last two examples I gave you, that is something that is in the BC Calculus curriculum, but it is an unbelievably minor part of the curriculum. So, you know, we are only going to talk about this pretty much in this unit, and it's never really going to come up again. I mean, I might ask you to take a derivative of an inverse function here and there in the future, but for the most part, I really wouldn't lose sleep over the fact if you think that this video is just totally confusing. But again, if you're confused, just come in during tutorial, come in during class, ask some questions, and I'll see you in the next video.